I'm Emily Dowd and I'm a third year PhD student at the University of Leeds, and I'm going to talk about my career path from being a meteorologist to studying atmospheric methane at Leeds. So so I'll just start off by talking about my pathway into research, kind of like why I chose to study science and my education, and then also I'll give you a quick summary of my research, kind of like the topics that I am currently looking at, and then I'll finish off with some details about an outreach project that I'm involved in. So from a very young age, I've had a strong interest in science. My dad did an Open University degree when I was growing up, and quite often in the house he would be doing random experiments, such as trying to measure the distance between the Earth and the Moon using like a standard household broom, and then he would also be there to answer any random questions I had about like why the sea is salty or why the sky is blue. And I think from that, I was really curious about the Earth around us. And I was really fortunate to be on holiday in America, and I experienced my first ever like really large thunderstorm. And after experiencing that, I really wanted to understand the processes in our atmosphere, like what happened in the atmosphere to cause such an explosive event. So I decided I wanted to pursue a career in meteorology from a very young age. So when I was out of school, I chose subjects such as physics, chemistry, maths, and geography. And I studied really hard and managed to get a place at the University of Edinburgh, where I did an MPhil in physics with meteorology, which was a 5-year degree. And in my final year, I did a master's project in methane, which was called Understanding the Recent Trends in Atmospheric Methane. And this is kind of an important thing to note for where I've ended up now, but I'll come back to that in a minute. So also when I was at school and university, I did quite a lot of work experience with the Met Office. So I did 2 weeks worth of work experience at RAF Lossiemouth up in the north of Scotland, where I helped to take weather observations and shadowed a weather forecaster, but also attended weather briefings for the squadrons that were based at the RAF base. And I also did 1 week of work experience at the Edinburgh office, where again I took some weather observations and also learned about quality control of weather data, which is super important for putting into weather forecasts. So after my degree, I reached my lifelong goal of becoming a meteorologist, as I managed to get a job as a maritime meteorologist with a company called Meteo Group, which is also now known as DTN. And I provided weather forecasts for lots of different customers all around the world. And these customers included shipping companies, offshore platforms, and also salvage companies. And it was a really good experience delivering all the different weather products for these customers. But after about 1.5 years in that job, I'd kind of gone as far as I could, and I wanted to learn more about our atmosphere, but also decided that project-based work was more for me, and I also wanted to improve my understanding of things in the atmosphere, and I also really wanted to work in a collaborative way with more people. So I started looking for other opportunities and came across the CENT-CDT. So the CENT-CDT is a Centre for Doctoral Training in Satellite Data for Environmental Science. And the project that I found was called Investigating Global and Local Trends in Atmospheric Methane. And after doing my master's project in methane, I thought this project was written for me, and it was like the perfect topic that I wanted to study for the next 4 years. And another great thing about the CENT-CDT is that it also includes a training program where we are trained in lots of different Earth observation techniques, which is super important for after a PhD when I might want to go into jobs that might not be just in atmospheric science. And another great thing about the CDT is that it's based between 4 institutions across the UK. So I have a lot of friends and colleagues at different institutions studying a wide range of topics, which is really useful for networking and also collaborating in different science topics. So my PhD project involves combining satellites and using a chemical transport model, and the one that I use is called Tomcat, and we use these tools to investigate changes in atmospheric methane. So why is methane important? So methane is the second most important anthropogenic greenhouse gas in our atmosphere after carbon dioxide. And anthropogenic emissions have contributed an extra 23% to the radiative forcing in the troposphere. But the problem is that global variations of methane are poorly understood. For example, in this graph here, it's just showing the global methane concentrations. And in between 1999 and 2006, the global growth rate stagnated. And then it began to accelerate again in 2007 and again in 2014. In the last few years, we've had record global annual increases. And one of the reasons the variations in global methane are poorly understood is due to the uncertainties in the drivers of the sources and sinks of methane. So methane has a mixture of natural and anthropogenic sources, and the largest natural source of methane are wetlands, but other major sources include agriculture and waste, fossil fuels, and biomass burning. And the main sink of methane, which is the process that removes methane from the atmosphere, is the hydroxyl radical, which is also known as OH. And we can't directly measure OH, which adds to the complexity of understanding what is driving these changes in global concentrations of methane. Another difficulty with methane is due to the observations that we have. So methane has, there's a surface network of observations by NOAA. And you can see here on this graph here that the blue dots show all the surface observations, and it's quite sparse global coverage with more observations in the Northern Hemisphere than in the Southern Hemisphere. These do provide long-term observations, but some sites don't have regular observations, which can add some more difficulties in analysing the data. And also there's less observations in areas that we find interesting, such as the tropics where wetlands are. We can also measure methane by satellite. So in 2009, the GOSAT satellite was launched in 2000. It was launched in 2009. It has a pixel size of 10 kilometers by 10 kilometers and provides global coverage of methane every 3 days. But you can see from this image that the spatial coverage can be quite sparse. So there is some missing information there. And then in 2017, a satellite was launched called Sentinel-5P, and on board that there is an instrument called TROPOMI. And TROPOMI measures methane with a pixel size of 3.5 kilometers by 7 kilometers and provides near global coverage every day. And you can see this is a massive improvement on the GOSAT satellite in giving us extra information. And it's allowing us to see methane in a way that we haven't done so before. So in my project, I'm using this new TROPOMI instrument to investigate changes in methane. So I've been investigating the large rise of atmospheric methane in 2020, and as I said before, it was the largest global annual increase on record, but this record was then surpassed in 2021. So I've been comparing the satellite data with the chemical transport model using optimized surface fluxes to make some comparisons. So just to kind of give a quick summary of my research, I've been using satellites and computer models to investigate atmospheric methane. And I found that when I compare the model with the satellites, we can capture the observed rise of methane in 2020 and found that in these regions, South Sudan, Uganda, and Canada and Russia have large increases. And from these selected areas, wetlands could be the largest contributor to this large rise in methane in 2020. But more work is needed to fully understand what is driving this change. So I'm currently developing a nested grid model for the chemical transport model Tomcat that we use in order to do high resolution comparisons with the satellite. So that's a quick summary of my research. I realise that we're probably running out of time a bit, so I'll just quickly finish off with the outreach project that I'm working on. It's called Sat School and it aims to introduce Earth observation concepts to 11 to 15-year-olds, and there's 12 plus hours of materials. And also, if you do have an interest in finding out more about Earth observation, you can head to our website and have a play around with all the really cool resources there. But yeah, but that's one thing that I really do enjoy as part of my job is doing outreach and trying to inspire the next generation of Earth and environmental scientists. But yeah, I will finish there. Thank you for listening.
Thank you very much, Emily. This is probably an unfair question, but have you got any idea what might come next in your career?
Um, I haven't decided yet, but I would really love to stay in research and stay in the field of methane. It's a really exciting time for methane with upcoming like satellite technology. So yeah, it would just be dependent on what opportunities are available, like possibly do a postdoc or try and on methane. So